So the last section today will be looking more specifically at these graphs. So I want to look at graphing this this function y equals negative 2x times the absolute value of x plus 3 and then plus 2 on the end. So what's your vertex? You can get your vertex from the opposite of hk, so that should be negative 3, 2. And what are the intercepts? Well, let's talk about this without necessarily looking at this transformation stuff yet. So remember that the x-intercepts are where your y is equal to 0. So if I put in a 0 for y, and I say, okay, negative 2 times the absolute value of x plus 3 plus 2. And remember that this comes from two functions, or two lines, so that we have to use a piece of each of them. So the two parts that we're going to look at are going to be, we're going to look at when we put in x, and whatever number is in here is just a positive number. Right? So you're looking at y is equal to, or f of x is equal to x. So that's a positive number. But we also have to look at the other side of things, and that whatever this number is inside the absolute value is technically a negative number, but because we're taking the absolute value of it, we get a positive. So for instance, if I put in negative 5 here, if I put in negative 5, let's look at it up here. If I put in negative 5 plus 3 is negative 2, but because it's inside the absolute value bars, I'm going to pull out a positive 2. So if I put in a negative 5 here, I'm still going to get negative 2, but because I got rid of the absolute value bars, I'm actually going to, that negative 2 is going to come out. I need it to be positive, so I'm going to take the opposite of that. So making a table might not be a bad idea for this example. So, so we're going to look at these two cases individually. So looking at, let's look at the one here on the left, and that just means that I'm looking at all values that are greater than 0, so that this number is always positive. So I'm only going to put in numbers like 1, 2, 3, 4. Of course I could put in decimals, but I'm just going to talk about the whole numbers right now, or the integers. So I'm going to put in positive numbers for x, and so when that happens, I am going to look at solving this for x, and I distribute the negative 2 and I get negative 2x plus 6 plus 2, and negative 2x minus 4 when I combine those two. I'm going to add 2x to both sides to get a 2x equals negative 4, so x is equal to negative 2. So that's one of the x-intercept, or one of your zeros or x-intercepts. Now, the other one, recall, comes from putting in negative numbers. So when I put in negative numbers here, I have to take the opposite of those when they come out. So I've got to take care of this distribution kind of separately. So what I did was I first distributed the that negative sign that's out in the front. So I distributed this negative here, and I distributed it to the 3, and then you got to stop because the brackets are there for me to be done with that. So that becomes negative x minus 3. Now on the next step, I've got to distribute this negative 2 inside the bracket. So negative 2 times x, and negative 2 times, oops, covered that up, negative 3, and when I do that, I have positive 2x plus 6 plus 2. So combining my like terms, I have 2x equals 8, or 0 equals 2x plus 8, and then negative 2x equals 8 when I subtract that 2x from each side. So dividing by negative 2, I get x is equal to negative 4. So I could start putting some of these points on the graph. We know that the vertex is at negative 3, 2, and we know that our x-intercepts, anyway, are at negative 2 and at negative 4, and that kind of looks like it should make sense. When you look at the transformations, this is being reflected over the x-axis. It's being vertically stretched by 2, so when we normally go to the left 1 and down 1, we're going to go down 2. and to the right 1 and down 1, we're going to go down 2. So where's the y-intercept? Well, I want to look at where x is equal to 0. So where is x equal to 0? So now the thing is, I could look at the other half of this graph like we did here, or the other half of this function, by talking about the opposite that comes out. But the thing is that if my x is 0, I'm not putting in any negative numbers. So I'm always going to get a positive number inside here. So I really only have to look at it once right now. So when I do all of this simplifying, I think I'm going to end up with, and my answer should be here somewhere, I think, unless I left it off. Well, your y is equal to -4. So I'm going to put that on the graph. Oops. And now, when you think about the transformations, I would describe these transformations as it's been moved left 3 units, up 2 units, and it has been reflected over the x-axis and vertically stretched by a factor of 2. So when graphing this one, your graph should look like this, because you're going to go to the left 2, or to the left 1 and down 2, and to the right 1 and down 2. So you should have this idea of the mirror image over this axis of symmetry. So left 1 down 2, right 1 down 2, right 1 down 2 again, and right 1 down 2, and it matches on the other side. So looking at comparing this one with the parent graph. So if I just kind of quickly put the parent graph on here, and I will graph the parent graph. I wanted to change the color of that one. I'll graph it in this color again, and maybe I'll make it a dashed line. When I graph it, it should have its vertex at 0, 0. So I'm going to have one side of the graph looks like this, and the other side is going to look like this. So using that as a comparison, this negative tells me it's going to be reflected. I always think it's a good idea to write down the transformations so that you don't forget what's happening. So reflect over the x-axis. Then the other thing is it's going to be a vertical compression or shrink by a factor of 1/2. And then it's going to be translated, let's see, 1 unit to the right and 2 units down. So that makes it nice and easy for me to be able to put the graph on here. So if I choose this again, and I will make sure that it's a solid line, and it is, and I'll change the color, let's maybe do a green one. And so it's going to reflect over the x-axis, so it's going to open upside down. Translated 1 unit to the right and 2 units down is going to put my vertex right here, and it's going to be compressed, so really it's going to be that I'm going to go 1 unit to the left and 1/2 a unit down, so it's going to look, and then more like this, 1 unit down, so it's going to hit at one of those crosshairs on every other one of these, like so. So it should be something like this, and then the other side is going to mirror that one, and will look like so. All right, so that should help you with being able to get these graphed. It's really very much like the transformations are exactly like you would use for the parabola. So let's go forward and see what's next. Write a function for the graph shown. Again, this shouldn't be a problem for you guys. You're pretty good at this. So we know that y is equal to, now I'm just going to check and make sure that I know I'm going to have a negative because it's upside down. And I normally would go to the left 1 and down 1, but notice I'm going to the left 1 but down 2. So that tells me I'm going to have a vertical stretch by a factor of 2, so the 2 goes there. I'm going to leave a blank so I can go back and put in the absolute value bars here. And then let's see. I know that I'm going to have x and it's going to be minus 3, and then plus 2 because it moved to the right and up to the right 3 units, and then up 2 units. So your graph should, or your equation rather, should look like this. So there's your function, and if you want it to be really terrific, you could put f of x equals there. So this one now is opening up, and again, I'm going to check to see, it looks to me like it's been vertically stretched, so my equation should be y equals, and no negative this time, and it will be 2, leave a space, x plus 1, and then plus, leave a space, and plus 3. So I can go back in here and put in the absolute value bars. So that really is pretty straightforward, I think, when it comes to writing the function for the graph. And that does everything for today. All right, so hopefully you guys are doing well, behaving yourselves, and I will talk to you again tomorrow.